Good morning, good evening, good afternoon, boys and girls. It's time to learn about spanning tree protocol. So let me just share the screen with you. Today lesson is a little bit short. The first part is only theory. We are going to learn about spanning tree protocol, and then the idea is to create a lab, a basic lab, also related to this protocol, spanning tree protocol. So what is it? What do you think when you are doing research about a Spanish tree protocol, STP, what is it? Probably, if you get to a job interview, they are going to ask you the following questions that we're going to see. So the first question is, what is STP? Spanish tree protocol, STP, is used in switch networks to prevent layer 2 loops. Why is it needed? All right, so there comes the question, why do we need it? When switches are connected with redundancy to ensure the network does not go down if a link fails, multiple paths appear to reach a destination. This can cause several serious problems, if not controlled. What are some of these problems that we will be talking about? Give me just a moment because I need to close the screen that just popped up. Give me just a second. There you go. What are some of the problems that we may encounter when we are working along with switches? Uh, Infinite loops, broadcast storms, and MAC table inconsistency. Let's go over each of them. So, infinite loops, a frame may circulate endlessly between switches. A frame may circulate endlessly between switches. Broadcast storms, links get saturated because broadcasts replicate endlessly. A MAC address inconsistency, addresses keep changing port consistently. Destabilizing, destabilizing is actually destabilizing the switch. So those are the three. When we're talking about working along with switches, and there is the importance of having redundancy and the spanning tree protocol properly configured. We may encounter some problems, and between those, we can have infinite loops, broadcast storms, and MAC address inconsistency. So let me just clear the drawing for a moment. Let me go ahead and go down here. Next question that they will ask you in a job interview, and it's possible they will ask you this because I've been there. What does STP do? So you are at a job interview and they just ask you, what does STP do? STP detects loops in that topology and blocks redundant ports, setting them to blocking state, leaving only one loop-free path active. If an active link fails, it reactivates a block link as a backup, ensuring high availability. Importance. STP is essential because it maintains LAN stability. It allows physical redundancy without risking network collapse. It is a standard IEEE 802.1d and 802.1w RSTP 802.1s MST implemented by many switch vendors. Without STP, a network with redundancy switches can collapse in seconds. Conclusion. In summary, STP acts as a traffic director that organizes a flow of data, ensuring there are never two routes that generate an infinite loop. There you go. We have covered the theory about STP, so it's time to get into the nuts and bolts of this packet tracer lab. So let me just open it and we can take a look at that guy. In fact, let me just look at for that topology. Look at that, how beautiful. We have PCA, PCB, PCC, and PCT. We have 3 switches connected and several interfaces. So it's time to configure this in Cisco Packet Tracer. Let's go ahead and open Cisco Packet Tracer. And this is what we are going to do. We're going to create this topology in our Cisco Packet Tracer. So let me just leave this for a moment. It might take a moment here. You will have, of course, this information so you can follow along the visual of this networking graphic and networking diagram, and you can complete your Cisco Packet Tracer lab before we start running commands and configuring stuff. So let's see if it is now open finally. Okay. We need PCA, so let's go with the PCs. We need 1, 2, 3, and 4 PCs. If I just hold the control key and then click in each of the PCs, I can just duplicate them without the need of drag and drop all of them. Okay, we have PCA first here. Then we have PCB over there, PCB. Now we have PCC here. And finally, what do we have? PCD is the last one that we have over there. So we have the PCs. Let me just put them together there in the right spot. Now we need the switches. We need 3 switches. So let's go with the rhythm. Let's go ahead and configure. I'm going to go to the instructions of the lab just to double check what kind of switches we need for this configuration. So let me just work on that for a moment. And let's take a look. It's 2960 switches, what we need for this topology and this is laboratory. So let's go with the switches. Let's do the same. Let's do a switch there and then control and we duplicate it and then control and we duplicate it. Easy, right? Let's start adding the name to these devices. So we have SW1 over here, SW1, SW2, SW2, there you go. And finally, SW3, SW3, W3. Almost. Okay. Now, time to plug everything together. Let's go ahead and stop sharing video so we can focus in this specific lab. We are going to do the following. We are going to plug some cables here. Plug some cables. Okay, now I want to share the video again. I just want to. Okay, let's go ahead and plug everything together. The first thing we do, FA01 to PCA. The second one is FA02 to PCB. The other one is FA03 to PCC. And finally, we have FA04 to PCD, as in David, or D as in Delta. Okay, we have fast Ethernet 0/23 to fast Ethernet 0/23, and the connection that goes from switch 2 to switch 1 to switch 2. Now, next connection, 24 to 24. So the port 24 to the port 24 over here. And the last one is 24 to 23. So let's go 24 to 23. There you go. Let's go ahead and type this topology. Something like STP lab or something like that. So STP lab. There you go. Now we have it. What do you guys think is next? Do you guys remember what we have been doing? The easiest step. We go to the PCs and we start adding that configuration for those PCs. So it says that apparently the default gateway is not required for intra-VLAN ping test. So let's see if we can just configure the IP address of this device without a default gateway to see if it works. For now, that's all we are going to configure. It looks like it worked. So let's go ahead and do that. First, the PC A, we have 10.10.10.11, 10.10.10.11. Then we go to PC B as a boy. We copy and paste the IP address that I will share with you in the documents. Is the 10.10.10.12. Okay, it's /24. There you go. Now we have to configure PCD. What is the last digit here? It's 2012. So let's just change a 2 here, another 2 over there, and it's /24. Okay, there you go. Amazing, amazing job. Congratulations. Now, next one, 10.20, that 20, that 11, 255.255.0. There you go. Now, let's see what happens if we add 11 here. Are we going to get a duplicated? Yes. We're going to get a duplicated error, and that's what happens when you try to add the same IP address that we have in the other section of the LAN or the network. So do you guys remember what is the IP address that we have for this one? We had 10.10.10.20.20.12 /24, 255.255. All 255s and 0. 255.255.255.0. Okay, it's time to do some magic here. Next thing we do, let's start adding that configuration on the devices. Let me go ahead and copy that configuration for the switch 1, SW1. Let's do an enable, config key. Let me just paste that configuration there. Are we getting errors? We are getting a couple of errors there. I'm going to do the following, just to cover my back. I'm going to raise the spaces, all the spaces, so we don't get any errors when trying to configure this, and then copy and paste everything again. So maybe those spaces are creating a problem there. So let me just work on that for a minute. It will just take a couple of seconds here. Okay, yeah, we're getting some errors, but it's part of the job because we still need to configure the other devices. So let me just copy and paste this one more time. Let me do a config T. Let me just paste it there. And there you go. Now I'm still getting the error. Maybe there are some commands that the device doesn't handle, doesn't support. So we're just going to ignore those errors for now. Let's go ahead and save the configuration. Basically, this is what we did. We just removed the spaces in the configuration file. And we're going to do that with switch 2 as well. Before adding the information, we do the same. We start removing those spaces. Of course, you don't have to do it because probably when I share this video with you and all this information, this job has already been completed. But look at that. It is essential and important to remove these spaces. Okay, let me just save the configuration real quick just to cover our back. Let me just copy that and let's go to switch 2. Switch 2, let me just go and do an enable, config key, then paste everything there. There you go. Let's do an end and a WR. Remember to do WR after applying the changes. So the changes are saved. Now we are only missing the last switch 3. Let me just work on that. It will take a couple of seconds here. Almost. Once we have this, we are going to go into the step-by-step process of all the information that we need to configure for spanning tree to successfully work on these devices. Probably it is possible that some of the configurations that we already have here might be repeated, but it's part of the learning process. So just ignore that if it eventually happens. Let me just go to switch 3. Let me do an enable, config T. Let me paste this over there. Let me do a WR, and there you go. Now we have everything plugged together. Everything is configured. What else? What else is missing? We have the PCs, we have the switches. That's it. We're done, right? Almost. We need to follow the document with the lab instructions. Let me go ahead and share that with you. Okay. Ah, ah, ta, ta. Mm, mm. Okay, this is the document. I will share this PDF file with you, and it's called STP Configuration and Root Bridge Lab. It's a basic to intermediate level. Lab objectives. Understand how STP elects a root bridge, default and force. Practice PPST plus per VLAN STP. Basic and verified port role state. Set priority, secondary route. Tweak path cost, priority, and observe changes. Use port fans and BPDU guard correctly on access ports. Optionally, compare classic STP versus rapid PPST. Plus, if the image supports this feature in Visco Packet Tracer, troubleshoot typical misconfiguration. So first thing we do is we have to plug everything together, connect all the PCs, connect all the cables, and start adding some configurations. So the first thing we do is create the VLANs. Of course, they are already created, but let's take a look. How is the process of creating a VLAN? Let's go to switch 2 and validate that specific process. So if we were to create the VLANs here, config T, VLAN 10, name, users, underscore, A. Then we have VLAN 20 or 20, name, users, underscore, C, and exit. And finally, we have VLAN 999, name, native, and then exit. Before we save the changes, let's validate that these VLANs are correctly added for the switch 2. We need users A, users C, and the native VLAN. Yes, those are the correct VLANs that we need. So we should be all covered on this. I'm just going to save those scripts so I can share the information with you guys later. Boys and girls. Okay, let me just close that and let me continue on this document. Next thing we do, add the trunking information, uh, allow some of the VLANs, and configure spanning tree protocol trunk. That is in FA0/23 to 24. This is a range. And basically, the way we configure it is we go to the device. Let me just go to the show run configuration. And you can see this one has the configuration already added. And that was with the range command. With a single command, we configure two interfaces. We are allowing some VLANs. Also, the native VLAN 999 is configured. And that's pretty much. Finally, the spanning tree port fast trunk is configured. So we have pretty much done all the configurations on the devices. Let's continue to see what else is important. Before forcing a root bridge to see which switch becomes the root by default, let's go ahead and do the following. On each of the switches, let's run this command, show spanning tree VLAN 10. Let's go ahead and do that. So there you go. We have a designated as a root. Both are in forwarding state. Let's run this specific command in the other switches. Let me just open this one, copy and paste it there. All of them are designated forwarding. That means we have the root bridge there. We are going to find out in a moment. Okay, so we have switch 2 here. We have switch 1. Yeah, this bridge is the root. So we even have a message that tells us that this bridge is the root, plus all the ports are in forwarding status. So that's another clue that we have the bridge, the root bridge. Let me go ahead and open the last one and paste that command. And these are alternate and block status for switch 3. Let's look at the lights. They don't really tell us that much, but we already validated the status of all these switches. And we confirm so far upon the first validation that the switch 1 has the root ID, and basically we got a message. This bridge is the root. We got that message, which is important. Let's see what else do we have important here. Let's go to the document, and we're going to do the following. VLAN 20, same command, but instead of VLAN 10, we are going to go with VLAN 20 at this moment. So let me just paste it there in all of the devices. Let me just work on that. And this one, I don't see a root bridge for this one. I don't see. Do you guys remember that before we have the switch 1 with the root bridge because all ports were designated? But in this VLAN 20, I don't see a root bridge. Because in order to have the root bridge, we will have the status of the port in forwarding and designated and forwarding. But let's continue with the document just to validate. We are looking for the root ID and also the different states: root, designated, alternate, and forwarding and blocking. Record which switch is a root for VLAN 20 and 10 and 20. Okay, so for VLAN 10 and 20, let me just take a look at this just to validate before we start doing some changes. What I can see, let's return to the switches. Usually they are in forwarding state. So we can actually validate and confirm that the root bridge is this one because we already have that. But we were checking and there was no mention on VLAN 20, right? Do you guys remember VLAN 20? It doesn't say there is like a root bridge for that one. So it doesn't really have it there. Yeah, I don't see it. I don't see it there. Do you know why? Probably is related to the priority value. Which one do you have for switch 1? Do you guys remember? We have the same priority value. It's actually lower, and that's the reason because this is the root, because the priority is lower here in VLAN 10. So the first thing we do in order to make the root port is configure this as primary. Let's go to the switch 1 and let's work on that. We do the following configuration. We configure this, and let's just validate something before I do that. Let's validate the configuration just to validate and confirm maybe we already configured that when we were doing the copy and paste. Did we did that? Yeah, we already configured that priority. So that has already been done. For switch 3, let's validate for switch 3. What do you have? Switch 3, let's do a show run here. Show run. Let me do again. Let me just complete it. For this one, again, we have the priority, but it doesn't say root primary. So for switch 3, we don't have this configuration. Let me go ahead and do that right now. Config T. Let's do a config spanning tree, VLAN 20, root primary. Okay, let's do an end. Let's do a WR for now. And let's go ahead and this is an optional step, but let's go ahead and go to switch 2 for a moment. And let's configure the following. Config T. And let's add the root secondary on this specific device on this guy. Let me just copy this information and paste it. Same information with the up arrow. We just changed from 10 to 20. And there you go. Let's do a 2WR. And there it is. Amazing. Okay, we're going to rerun the show spanning tree on all switches for VLANs 10 and 20. So let's start with switch 1. Let's do a paste. And look at that. It is still the root bridge. It is still the root bridge. What happened? We really didn't change much because if you guys remember, we did the configuration at the beginning and it's basically staying the same. We didn't change much there. Now let's see for VLAN 20 to see if we have any changes there for this switch 1. Not much. Let's go ahead and run the following. Let's go ahead and run this command on the other switches. Let's start with switch 2 here. Let's do an end and paste it. Okay, designated and root. They are in forward state. That is the role. And we're going to run that one in switch 3 as well. It's pretty much the same. We don't see major changes. Note that the role of state changes on app links, which are now blocking and forwarding. So let's see which ones are in that status. Blocking and forwarding, and that is actually in switch 1, where you have the blocking and forwarding state. Now, I'm wondering if we can actually increase the priority. Let's see if we can do that. And select another root bridge for this. Let's see if that part is available here. Oh, okay, there is some tweaks there for the devices. Okay, before we do that, let me go ahead and do something here. Let's say that this one, instead of being this priority, let me do a show run here real quick. Show run. Let me go ahead and remove this command for a moment. Let me just copy and paste it, and let's do the following. Config T. Let's do a no. Let me just paste it there. Let's do an end. Let's do a WR and show spanning tree. Okay, are we getting something different, guys? Do you guys see something different for that? I see something different, but still is still the root. Let me run that command again. The one for the show spanning tree VLAN 10. Let me just run it again on all switches. Okay, look at that. This one is not the root bridge, and this one is not the root bridge. Interesting. Let me just run it one more time. For VLAN 10, I don't see the root bridge here. Do you guys see it? No. It is not the root bridge anymore. You see forwarding, blocking, and forwarding. for the rows of root, alternate, and designated. So let's see the rest of the devices to see who is the root bridge now. Okay, let's go slowly. We don't have to worry about this. Let me just organize them in a better way so we can see it. Let's go with switch one. Do you guys remember what happened when we applied the changes, the last changes? The state change, and we are not seeing the root bridge here. This one is not. Let me just do it here. I don't see it anywhere. That's strange. Let me go ahead and do the following. Let me add this priority to one of the other switches to see if hopefully after we run this change, we will have another root bridge. Let's do a config T. Let me paste it there. Let's do an end. And let's go ahead and run it one more time to see if, there you go. Now, switch 3 is the root bridge. And basically what we did was to change the priority. Let's go ahead and config T. Let's do a no. Paste it there. Let's do an end and WR. And let's go ahead and leave it as it is from the beginning. Let's do a config T here and paste it. Right now, we're going to do an end here and validate that that configuration we have just completed give us the switch one as the root bridge. Do you guys remember what was the command that we ran in order to validate this? This one, show spanning tree VLAN 10. Let me go ahead and do that. There you go. There you go. Now I want to do something else. The other one that we apparently configure as a root bridge was switch 3, but for this other VLAN. So let me go ahead and validate that on switch 3. Let's do 20 here. But it doesn't really this. That's strange. Let me see what is going on here. Did we erase it by mistake? Let's see. Give me just a second. Let me copy the command one more time to see if we're missing something. There might be a misspelling error. That was actually switch 3. Yeah. So let me just paste it there. Yeah, it is the root bridge. So we did the change, and now this one is the root bridge. We see all the forwarding and designated rows, which means this is actually the root bridge. Amazing, right? Let's continue with the learning process. Now we're going to increase the code of one trunk to influence the port rows on the non-root side. So let me share the video for a moment. Let's go. Where are we going to do this configuration? Oh, it's in a specific interface. It doesn't really say where. So let's just choose a random switch. Which one has FA0/24? Okay, you guys remember it was switch 1. So let's go with switch 1. Let's work along with it. Let's do the changes. Let's do config T, interface FA0/24, and let me just paste this configuration. Okay, copy and paste it there. Let's do the same thing for 20. We just changed 20 here. We're changing the cost to 50. Let's do an end and a WR. Now let's validate the changes. First, just spanning tree VLAN 20. Let's go ahead and see that. Do you guys remember what we have before for VLAN 20? On the cost, it was 19 for some reason. Now it should be 50. So let's take a look to see what happened. Do we have the 50 for the cost? Can you guys see it? Let's see. For VLAN 10 and VLAN 20, there should be another cost, but I don't see it there. Am I missing something? That's the big question. Let me just do it again for VLAN 20 just to see. Oh, there it is. This one is a cost of 50 in port 24. Let's validate the other one, and you can see it there. It was in both for VLAN 10 and VLAN 20. It was there. It was down below where it says cost. Now it's not 19 any longer. It is 50. So this is the change that we have just done. Change cost on different links and watch which port becomes alternate blocking. Record your observations. Let's take a look to see which ports are blocking. Now we have the one with the higher cost, alternate blocking here. And what about the other one? Yeah, let's see about VLAN 10. Do we have the same? This one doesn't really change to alternate blocking because this is the root bridge. So everything is in forwarding state. But if you can take a look at this one for VLAN 20, it is in fact alternate blocking with a cost of 50. Or reapply the access port on in part B. Okay, port pass is for edge port only. BPDU guard protects against accidental loops by shooting the port if a BPDU is received. Okay, we have this script. It says already applied on access port in part B. Test the BPDU guard temporarily connecting to the switches. The port should go error disable. Okay, let's see if this is supported because since we're working with packet tracer, sometimes the commands are not supported. And in fact, this is not supported only in real Cisco equipment. So we might have to do this part of the lab later with the GNS3 in order to validate this or with a real trick and equipment. And this is to recover from error disable. What do? We execute the following command. We execute error disable recovery cost BPDU guard, error disable recovery interval 30 and end. That's it. Okay, now let's see if these commands, we have already checked most of them, but let's see if this summary command is supported. So let me run this. And it looks like it is actually supported in the packet tracer. So nice. Spanning tree summary. Show spanning tree summary is the command that I'm talking about right now, and we will go over the information in a moment. I just want to organize everything. Give me just a moment here just to have it there. Okay, let's go with the switch tree to see what do we have. We have the switches in PVST mode. We have the root bridge for the default user C native. Extended system ID is enabled. Some of the information for port fast and port fast BPU guard is disabled. Also, the uplink path is also disabled. You can see some of the statuses for the different VLANs. We have blocking state, and we have the forwarding STP. In this case, we have 4, 1, 4, and 2. Those are the amount of ports that are in those different states. And this one is actually 11. So it's a higher number there. It's pretty much interesting. All the information that we can gather from a single command. Okay, simulate a link failure to see what happened. Okay, let me go ahead and shoot down a port. Let me go ahead here, config T, interface FA0/24, shoot. And let's see what happened with this. Let's see what happened with the ports. Show spanning tree, VLAN 10. It just disappeared completely. VLAN 20. Yeah, only the facilitator 0/23 is up and it's showing information. The /24 connected to switch 2 disappeared completely. Are we running this in switch 2? Of course. Let's see what happened on switch 1. So spanning tree VLAN 10. Pretty much the same behavior, but it doesn't really affect, and we can see it. Before, did we have like the configuration of that specific device? No, because it's not directly connected. So most of the changes happen in the directly connected switch, which is switch 2, and that is the behavior that we currently have. We want to go back to normal, config T, interface FA0/24, no shoot, and after a couple of seconds, it will be coming back to normal. Let's see, show spanning tree VLAN 20, there you go. What about VLAN 10? There you go. It's actually listening state. So it will take a moment. Remember, um, spanning tree is not that fast. For that, we have rapid spanning tree, which is another version we might configure in this lab. But let's just run the commands again. For VLAN 10, it is in learning now. And what about VLAN 20? It is forwarding and forwarding. Let's see VLAN 10 again. It is now forwarding as well. Nice, nice. Great lab. A lot of learning today. Okay, so we have done the configuration. We have validated the states, all the changes that happen. If we unplug a cable, we can just do a show spanning tree VLAN and a specific VLAN to understand the behavior of the switch and the interfaces. Okay, so we have pretty much run most of the commands. Some of them are not supported in Packet Tracer. This one is still missing, so let me just copy this one and run it in switch 1, for example. And basically show running config 5 sections. Spanning tree will give us like a summary of all the spanning tree information that we have configured in this specific switch. Are we missing anything here? Only the interface error status. That happened because we were trying to run this, but it might not be supported in Packet Tracer. We're going to give it a shot. No, it is not supported. So we may have to do the use of an emulator like DNS3, for example, in order to run those more advanced commands. Or even if you have an spare switch at your home, you can do it. You can do it. Just remember that before plugging the device and everything, you have to make sure the switch doesn't have any configuration on it, and it is not recommended to connect it to a production network because it could create a chaos, a problem, and a nightmare per se. I think we are pretty much done with the lab. It's a lot of learning, a lot of practice and commands. I urge you to complete this lab yourself to practice all these commands. And remember, practice makes perfect. So it's been a pleasure. My name is Cesar. Boys and girls, take care and have an amazing week. Until next time, see you.